Hear me now? Hey, hi, buddy.
Yes, sir.
Yeah, perfect. Thanks.
Hello, sir.
Yeah, tell me. Yeah,
Yeah, sir, are you going to take advance?
who said that? Hey, guys. We have done with all the basic concept of the EIGRP, and today we're going to start the two topic, right? EIGRP stuff and EIGRP name mode. Someone mic is on. Can you mute your mic? Okay. Before I'm going to start these two topics, I'll let you know the first thing about the packets of the EIGRP. That's very, very important. Someone mic is on. So one we have a hello, one we have update, another we have a query, and one we have acknowledge, and then we have a reply packet, right? This packet, the hello and acknowledge packet, right? The hello and acknowledge packet is not reliable. It's not a reliable packet. The hello and acknowledge packet, 1 minute. Hello and acknowledge packet is not reliable. The update packet you have, then you have a query packet, and you have a reply packet. All this packet is reliable. Okay. Why this guy is reliable? Because whenever you're sending this packet, right, always you will get the one acknowledge. Doesn't matter either you're sending the update packet, query packet, and reply packet, always you will get the acknowledge. And why this packet is reliable? Just because they have a sequence number field, right? And the sequence number is a 32-bit number, and always this sequence number will increase by 1. After that, we have seen that on a router number 1. Okay, let me draw the scenario. EIGRP stuff. Good. Oh, not interested in this one. Let's start on this one. This guy, this guy, this guy, this guy, this guy, this guy. I'll do this one right now. And all good, right? 23.0, 24.0, and 12.0. So we have stool back behind R1 and this guy. I'll take the screenshot. Who and now, oh my god. Okay. So what I told you, right? If you remember, if you lose some information, right? Whenever the router is losing some information, for example, right now, if you have a look on a R1, R4 routing table, we have this information, right? I'm talking on the 1.0.0.0 and 11.0.0. At the same time, on R3, we also have this information. On R2 also, we have this information, right? And on R1, this has a connected route. These are the connected, and these are connected route, and this is connected on R1. On the rest of the router, they have learned this information from the EIGRP, right? From the neighbors. All cool? Now, try to understand one thing. What happened if I'm going to lose this information? Which information? This guy. If I'm going to lose this information, what happened? R1, R1 will send a query packet to the R2. R1 is asking, hey, R2, R1 in the query packet, they will put this information 1 or 0 or 0 or 0 or 0 with the infinite matrix, right? And R1 is asking to the R2, hey, R2, do you have any alternate path to reach this guy? R2 will say that I don't have, let me ask to my neighbor, right? R2 will ask for the same information to the R3. Same packet, query packet, 1 or 0 or 0 or 0 information, and same information infinite matrix. R3 will say that, hey, I don't have information. R3 will ask to the R4 query packet and same information 1 or 0 or 0 or 0 or 0 or 0 infinite packet. Try to understand what I told you, that your query packet is what? It's a secure reliable packet, right? Query packet is a reliable packet. So if it is a reliable packet, always you will have acknowledge. So what R3, R4, and R5 will do first of all, this guy, all this router, this guy will give the acknowledge, this guy will give the acknowledge, and this guy will give the acknowledge. And this is the acknowledge of what? This is the acknowledge of query packet. After that, what happened? This router number 4 will give the reply packet. Hey, I don't have any information about this guy, right? I don't have any information about this guy. Which guy? 1 or 0 or 0. And I don't have any information about this guy reply packet. Once the router will receive the reply packet, what happened? Router will send the query packet because my reply is not acknowledged packet, because my reply is also what? Reliable. And after that, what happened? Every router is going to delete this information from the routing of this guy. No information, no information, no information, and no information. This is the normal behavior whenever you are losing some information. So whenever you are sending the query packet, right, you always get the reply packet from the neighbor. Always. And reply packet is also reliable. And it always, right, unicast. So if I'm asking you, what is the meaning of query? Query means what? I'm asking, I have a doubt, right? Query means what? I have a doubt, I have a questions, I'm asking to you. You have to give me the reply. Doesn't matter you are giving the positive reply or negative reply. Doesn't matter you are giving the positive reply or negative reply. But you have to give me the reply. Can anyone tell me which reply is this? Is it positive reply or negative reply?
Negative.
Negative reply.
It's a negative reply, right? Because they don't have any alternate path to reach this guy. R2 does not know anything about the alternate path. R3 even don't know, and R4 even don't know, right? So they will give the negative reply. And once R1 will get the negative reply, what happened? Everything is fine. If you have a look till this point, one minute, mute your mic. Someone mic is on. So see that your mic is on. Now, if you have a look on the R4 routing table, show IP, you can see the all the IP address is pre-configured on the router, right? According to the diagram, everything is there. Show IP route, and you can see I do have information about 1 or 0. That is, I'm interested on this route only, right? This guy only. And I have a 11 as well as, and I can send the traffic ping. Right? What happened? Let's go on R1, and I'm going to enable the debug EIGRP packeters, right? Debug IP routing. Show history. Come on. R3, R4. Now, I'm going to lose this information on R1. This loopback, interface loopback number shut down. Do you all, you all, and you all. Can you see that what happened? Understand from the R1. R1 has lose the network loopback number one, and this network is shut down now. So loopback one is removed from the routing table. So delete this route in from the routing table 0.0 means what? It's a directly connected route. And I'm encoding the query packet. Encoding means what? I'm putting the query packet into the queue. Every router has a queue. Okay, so I'm putting this packet. I'm sending this packet to whom? I'm sending the query packet to the 12.2, right? From 0/0 interface. And this query packet is a reliable packet. That's why we have a sequence number 7. They don't have any acknowledge number. That's why they are putting the acknowledge number 0 over there, right? So sequence number 7 over there. And now I'm sending this packet to the router number 2. And in this query packet, I'm just going to put the which information, my this information 1.0.0/8, right? Once the router 1 will send the query packet to the router number 2, what happened? Now router number 1 is giving the acknowledge. Router number 2 is giving the acknowledge. This one, can you see that? And this is the acknowledge of same sequence number 7, and he's giving the acknowledge number over there, 7. Once R2 will receive the query packet, what they will do over there? See, I'm receiving the query packet from my neighbor 12.1, right? And I'm sending the acknowledge packet to this guy because query is a reliable packet. At the same time, what happened? I'm sending the query packet from which interface 0/1 to the R3, right? And I'm putting the sequence number 13, and I got the acknowledge of the 13. Same thing if you go back to the R3, R3 will receive the query packet from the R2, right? After that, I'm sending the acknowledge back, same sequence number 13. 13 is happening on this guy. Acknowledge number 13 over there because this is the acknowledge packet. Acknowledge packet does not have any sequence number. They just have a acknowledge number. Cool, right? What R3 will do? R3 is asking to the R4, hey, do you have any alternate path to this guy? What happened? Receiving the query 34.3. That's my neighbor 34.3. R4 is receiving this packet, right? What R4 will do? He send the acknowledge packet, and after that, what I'm deleting this route, of course, because this route, this query packets contain the infinite metric information. And after that, what I'm sending the reply to which one? 34.3. And this reply is what? Unicast. Once I will send the reply packet to the R3, R3 will give the acknowledge, right? Can you see that? So reply is what? Sequence number 6. Reply packet contains the acknowledged number and sequence number as well as. So they have a sequence number 6 and the receive acknowledge of the 6 over there. R3. What R3 is doing over there? R3 will receive the reply packet from the 34.4. This is the unicast packet. That's why we have a neighbor information, right? And after that, what I'm sending the acknowledge, right? And I'm sending the reply to whom as well as 23.2. That is R3 to R2, right? And then I got the acknowledge from the R2. Once R2 will receive the reply packet, can you see that? Was receive the reply from the 23.3. I will delete this information from the routing table and I'm giving the acknowledge. So once R2 will give the acknowledge to the R3 about the reply packet, now what R2 will do? R2 will send the reply packet to the R1, right? So sending the reply to R1 and R1 is giving the acknowledge. And now come back to the R1, and R1 is, you see, I received the reply from the R2, and now let me send the acknowledge. Everything is so far good. Nothing has issues. Nothing has issues. And always, if you send a query, right? Query, always if you send a query packet, you will always give the accept the reply. Always. Because query, like, the response of the query packet, I need to use the reply packet. I cannot use the acknowledge, right? I cannot use the acknowledge because acknowledge is not a reliable packet. I need a reliability. Take example. What happened? R1 has sent the query packet to the R3. This information. Not R1. R3 has sent the query packet to the R4, right? R3 has sent the query packet to the R4. What R3 is expecting? On this particular interface, R3 is expecting the reply packet. What happened if R3 is not able to receive a reply packet from the R4? What happened if R3 is not received? R3 has sent, right? R3 has sent the query packet to R4, and R3 is now waiting, right? This guy is now waiting for reply. This interface is now waiting for the reply packet. R3 has sent the query packet. Now R3 is waiting for the reply. But what happened? Just because of the maybe on this router, right? Maybe on this router, what happened? The CPU is high, right? That's why what happened? The R4 hasn't processed the query packet. Maybe the link get congested. Maybe the CPU is high. Maybe the link get congested. Maybe on the router 4, the queue is out there. The queue is totally full. Because of the queue is full on the router interface, what happened? Maybe they are not processing the packet, maybe some delay is happening. Because what R3 is doing, R3 has sent, right? They sent the query packet from this interface. They sent it. It's done, right? The packet is in the middle now. The packet is in the middle now. Maybe on this particular interface, this kind of issue will be happen, right? And because of this reason, what happened? The R4 is not sending the any, someone mic is on, any reply packet to the R3. If R4 is not sending any reply packet to the R3, in that case, what happened? Once I lose this information, right? Once I lose this information, 100.0.0.0/8, immediately what R1 will do, it put this route. Right now, this route is present in the which state? If you remember that EIGRP topology table has two state for the route. One we have active, one we have a passive. By default, it will go for the passive, right? The default is passive because once you put the network step, you can see that on R1, do show IP EIGRP topology table. All they do have a passive by default, and passive means what? It's good every single route. But at the same time, we have active as well. As once I lose this information, right, 1.0.0, what happened? Immediately it will move from the passive to the which state? Now this is called as a active state. And in this active state, which route is moving? 1.0.0/8. R1 will put this information into the active state once they will lose this in right in the, and this in this active state, this route will be present as an infinite matrix. Also, you don't write this thing right. For how many second? For 180 second. That is, we can call this guys a 3 minutes as well as. This is called as a EIGRP active time. It means that the router one is looking, right? Router one is looking for an alternate path for this network, right? R1 is looking an alternate path for this network 1.0.0/8 for how many seconds? 180 seconds. If you get the reply, within a 180 second, everything is so far good. If you are not getting the reply within a 180 second reply packet, I'm talking about, because in the response of the reply, right? Sorry, in the response of the query packet, you will always get the reply. So I'm waiting for the what? Reply packet. What happened if R1 is not received the reply from the name? Because waiting the reply, right? Because if R3 will give the R3 has sent the query packet to the R4, R4 has to send the reply to the R3, then R3 will process the reply to the R2, and then R2 will process the reply to the R1. But R4 is not giving the reply. This guy has to wait for the 180 second. If I'm not getting the reply till 180 second, what happened? After that, R3 is going to break the neighbor relationship with the R4. R3 is going to break the neighbor relationship with the R4. Which reason? As we know that the good thing about the EIGRP is giving the reason whenever they are dropping the neighborship. Whenever the router EIGRP drop the neighborship, always they are giving the reason. And in that case, the reason will be what? Stuck in, because my this information 1.0.0 has moved in the active state. And due to this reason, what happened? I wait for the 180 second, I didn't get the reply from the R4. Now this route has moved in the stuck. So what R3 will do, because R3 is not getting the reply from the R4, right? R3 is not getting the reply from the R4. So what R3 will do, R3 will break the neighbor relationship with the R4 just because of the stuck inactive. They will say that, hey, this route has moved in the stuck inactive state. And I'm waiting for your reply. If you're not saying the reply, I will drop the neighborship. And this, why R4 will not send the reply packet? It could be any reason. CPU high, link congested, R4 queue is full, and maybe some delay is happening. And guys, I'm telling you, this is not a big deal. This one is not a big deal in the production. Because normally in the enterprise network, right? Normally in the enterprise network, what happened? Normally in the enterprise network, you will have a 100+ router. Anywhere can a mistake will happen. And can you take example, if you have a VPN configure, right? DM VPN scenario is happening like this one. Take example. If you know it's good, otherwise don't worry. I'm just telling you who has have aware with the DM VPN, then it's good. R1, and we have a R2, then we have a R3, then we have a R4, and then take example, this is the ISP over there, and this is the headquarter branch we have in the USA, and we have a branch office, branch 1, that's in the Delhi, branch number 2, that's in the we can say the UK, and branch number 3 we in the Australia, right? I have a like this connectivity right now, And what happened? I'm going to create a one cloud over there, DMP pin. And on this DMP pin network, I'm going to run the EIGRP. Can you imagine what happened if this network goes down, right? It will send the query packet from Delhi to the headquarter, and from headquarter it will send to the UK, and it will send to the Australia as well. As anywhere delay will happen, right? Anywhere, it's not a big deal. I'm running with the EIGRP, and the behavior of EIGRP, if you're losing something, you have to send the query packet. And if I'm sending the query packet, I need to have a reply packet. What happens if this guy, if the Australia will not give the reply? R1 is going to break the neighbor relationship with Australia. So can you imagine if you have a bank branches, right? If you have banks over there, and these are just a one bank branch, all the sites, whatever the sites you have in the world, all the site is going to drop the neighbor relationship with this person. And this has just happened what? Maybe this LAN network that is enabled with the EIGRP get flapped. Because if I'm going to bounce the interface, shutdown and no shutdown, what happened? You are sending the query packet. And if somehow, whenever this person is sending the query packet, in meantime, what happened? This guy has some delay on the router side, and then maybe this guy or the router has the queue is full. He is not able to give the reply. Complete this guy has to lose the relationship with the all the sites. Okay, that's not a big deal. After some time, maybe the 3 minutes and 2 minutes, the network engineer has resolved the issues, right? And it will working fine. But again, what happened? For the few minutes, your network is down. And what do you think? The flapping of the interface in the LAN network. It's a tiny things, right? It's not a big deal. It's just a tiny things. It can happen, right? So if you just losing, right? If you just interface get flapped, or what we call, if the interface goes down, you are sending this amount of packet, right? At the same time, forget the forget the neighborship right now. Forget the neighborship. Forget the neighborship will break, right? By if the router 4 is not sending the reply packet. Can you imagine whatever the wastage of bandwidth is happening on this particular link, whatever the wastage of bandwidth of this particular link, and whatever the wastage of bandwidth of this particular link? Because I need to send the query packet on every router, right? So it doesn't matter how many branch office you have. If you're running with the EIGRP, that's a behavior of the EIGRP. It will send the query packet to every person, right? And it wants a reply packet from the neighbor. If the person will not give the reply packet, I will break the neighbor relationship with that person. This is the behavior of the EIGRP routing protocol. The router will just wait for the 30 minutes, sorry, 180 seconds, 3 minutes for the reply. If I'm not getting the reply in that particular timer, you can modify this time. That's not a big deal. That time is known as active timer. I will break the neighbor relationship with that person. Only to that person who is not giving the reply. R3 is giving the reply, right, to the R2. R2 is giving the reply to the R1. But R4 is not giving the reply. So R3 will break the neighbor relationship with the R4. So whatever the user are sitting behind the R4, and whatever the user are sitting behind the R3, and whatever the user are sitting behind the R2, and whatever the user sitting behind the R1, they cannot communicate with this person. So if you have a look, what I can do right now, I'm just going to up this interface. Okay. If you see, come on, do show IP EIGRP traffic. Can you see that I have sent the query packet and I received the reply as well as this is the sent, right? And this is the reply. All good. Now What I'm going to do, I'm just going to up this interface right now. Interface loopback number 1, no shutdown. The interface loopback number 1 belongs to the 101 IP address. Oh, good. Come to the R4 now. Show IP route EIGRP. I do have this information 101. Right? 3200799139. Can you put your name? That will be good for me, right? So that I can pronounce. Otherwise, I have to call this guy 32079139, and it's totally, I know, it's wasted of time for me as well as. Now, I can ping it, right? Let's do one thing. Debug EHRP packets, cures, and debug IP routing. Show history. Done. R3 and R4. All good? Now, right now, I cannot do like this, right? If you see this, where is that? I cannot make a CPU high on the router now 4 and link get congested and RPQ is full. I can do one thing. I'm going to increase the hold on time of this particular interface as a 500 second. The hold on time I'm talking what? Why I'm increasing the hold on time? Because the default hold on time is what? 15 seconds, right? I'm going to increase the hold on time to just show you that, because the active state is what? It's a 180 second. I want to show you my neighbor state will be get dropped just because of the stuck in active, not because of the hold on time expire. I want to show you this message, right? I'm just going to increase the hold on time so that it will not affect to the neighborship, right? Just because the hold on time expire. And I'm going to create the one ACL, and in the ACL, I'm going to deny the EHGRP to just show you the behavior, right? All this thing. Now, come to the R3, which interface we have, this guy. Interface R30/1, IP, hold on time, EHGRP number 1, 500 second, and on R4 as well as config terminal interface 0/0. IP hold on time EIGRP number 500 second. Come back to the R3 access list on the deny EIGRP ini, and I'm going to call this guy IP access interface 0/1, because I cannot create the the convention over there. So I'm just going to deny the EIGRP in one. Done. Now let's go on R1 and shut down this interface. Stop and do show IP EIGRP topology. Can you see that the route has moved in the active state? Right? Wait for some time. I'll show you each and every output. Do show IP EIGRP topology 10000, infinite metric. Do show IP EIGRP topology active state. Metric is what? Infinity for this particular network. Show IP EIGRP. Okay, or what I call traffic. I have sent the query packet, right? To I haven't received the reply till now, because this is the previous reply, right? This one is the previous. And go back to the R3 now. What R3 is doing is keep sending the query to the R4. Just keep sending the query to the R4. Wait for some time more, 180 second. Stop. stop this guy now. I can come back and done. I'll explain you this packet. Don't worry about that. Right now, R3 keeps sending the query packet to the R4, right? And if you see, my still neighborship is up right now. Show IP, do show IP EIGRP neighbor. I have a neighborship, right? R4 is also sending the reply packet to the R3, but on R3 the ACL is configured, right? I have configured the ACL over there. Not this one. EIGRP hold on time is 500 on this guy, and I have configured the with the ACL. Access is denied over there. So wait for some time more. 180 seconds totally right. So reply. He's sending the query packet. R4 is also giving the reply, right? R3 send the query packet to the R4, and R3 is also giving the reply. Can you see? But R3 is not accepting the reply because on this particular interface, I have called the ACL, and ACL is denying the EIGRP. He's sending the reply, right? He's receiving the query.
So that ACL is dropping the reply
Yeah,
packets,
that's
right?
yeah, exactly right. Now all good is done. So do you all? So do show IP EIGRP if you see neighborship. I don't have a neighborship with the 4. The neighborship R3 does not have a 4. They drop the neighborship. I just have a neighborship 20 there. And why they are dropping the neighborship? Can you see that? 1 minute. Let me do you all. And on R1 as well as you all. On R2 as well as you all. And if you see the behavior, I'll show you the first from here, right? Apps are down this particular, I'll come back to the R1 guys. Apps are down this particular link. What happened? This loopback has down. I'm sending the query packet to the R2, right? Receive the acknowledge. Understand sequence number 9. Send the query sequence number 9. Receive the acknowledge with the 9. Is done. Query and acknowledge. Done. Now, forget this master right now aside query. Come back to the R2. This is the message happening on R1 right now till this point. Okay, this is the debug routing debug just perfect. And receive the query from the 12.1, right? 9 and giving the acknowledge with the 9. Perfect. And I'm sending the query to home 0/1 because I'm asking to this guy as well, hey, do you have any alternate path? All good. Forget this message SI query in server right now. Now R3. So use message. Come. Oh, this one. I'll apply the ACL is configured. This point is also noticed, and the hold on time is 500 seconds, guys. This is the pay. This is the important point. Receive the query from the 23.2. R3 has received the query from the 23.2, just some neighbor, and I'm sending the sequence number 17. I'm giving the acknowledge of 17. So this is done. This section, this segment has complete, right? Now, R3 is asking to the query to the 0/1. This guy, 0/1, he's sending the query packet. Sending. Am I receiving any reply packet? Sending, only query sending. Am I receiving any reply packet? No. 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 Now, wait for some time. R3 has sent the query packet to the R4. Did I get any reply and acknowledge packet? No. How many retries happening? Retransmit out 500, 5,000 millisecond, 5 second almost. Important point you have to see. Which sequence now I'm sending? 17, right? What's the retry is happening? 1. Hey guys, I have done with this part, okay, and this part. I'm talking about this perspective right now, this section. Right? Retry is 1, sequence 117. Then again sending query packet, same sequence number. Retries 2, same sequence number, retries 3, and so on. Sending same sequence number 17, retries 12, same sequence number 17, replies 17, same sequence number 17, replies what, 23.
No, yesterday you said it would be 16 tries, right? Retry.
Sorry, what? See,
Before.
16 will be happen if you have a slow EIGRP is going to be works on the slower media as well as on the slower media. What happened? The link will be what will the link of say that on that? So T1 link was there, not the on the older time. The slower link was there. On that time, what happened? The EIGRP is going to the 60-second and 180-second hold on, like hand to hand hold on time go there. One second. In that case, the 16 retries comes in the picture, right? And the 16 retries comes in the picture of the update packet.
Okay.
Now, hey guys, what is the half time of 180 second? 90. The half time of 90 second, what happened? Sorry, what half time of 180 second is 19, right? If you see what R1 is doing, once R1 has sent the right this query packet, after that a query and acknowledge. See, did I get the any reply packet from R2? Sorry, yeah, R2. No. So what R1 is asking? R1 is sending the next packet that is called as a SIQ. Stuck in active query packet. R1 is sending the stuck inactive query packet to the R2. Hey R2, whatever, now I can come back to this point, right? Whatever the task that I gave you, this stuck inactive query packet has like introduced in the newer iOS version. In the older iOS version, if I'm going to talk about the below the 10.0 iOS version, right? It was not there. It's introduced in the new iOS. So what SI query is asking to that, hey, whatever the task that I gave you, are you working on that task? I asked you something, hey, do you know the alternate path of this guy 1 or 0? You didn't give me the reply. Again, I'm asking. Once it reaches to the 90 second, 0 to 90, right? Default is 3 minutes, 180 second, right? The active time. What R2 is giving me? Yep, I'm working on it. I'm working on it. Now R2 is asking same thing to whom? R2, hey, R2, R2 is asking to R3, hey, what are the tasks that I gave you? Are you working on that one? So he gave me the SI reply as well as, yes, I'm working. And he also gave the reply, SI reply, yes, I'm working. If you see the SI reply, you know the every packet, right? If you see the SI reply packets, SI reply coming from the 23 or 2, and if you see, the first thing is that this packet, the query packet, is the unicast. So let's go here, GRP, same person. Output is 10. Same infinite matrix, right? I'm still querying, right? I'm still querying about this guy. What R2 is giving. Sorry, R3. Hey buddy, I'm working. SI reply. About this guy, I'm working on it. Just give me more 90 seconds. Now R2, if you see, send the query packet to the R3, right? R3 get the reply as well as. Now come back to the again R3. I have sent the more than 90 and 20 query packet to the R4, but he didn't get the reply, right? Again, what I'm asking. Not this one. If you see, I'm putting the packet on the queue on 0/1 34.4 SI query, right? This is the SI query received from the 23.2, right? And what's that? It's not giving that. He's not showing the sending the query, right? He's putting the query SI query on the interface. Not showing that output. This is SI query. Is not showing that. You can see that he's putting the query packet on the 34.4, right? But still, what happened? He also sent the one SI query to this guy. But still, I didn't get the reply for SI reply. Then again, what happened? It will wait for the more 90 seconds. Go, and still send the query. 29, 31. So same sequence now is happening. And after that, what happened? Once the 180 second has crossed, right? Once the 90 has reaches to the 180 second, what happened? R3 is going to break the say that hey, my this route has moved in the stuck inactive 100/8. Why they are moving in the stuck inactive? Because I have sent a lots of query packet to you and you didn't give me the any reply, right? So my neighborship 34.4 is down just because of what? Stuck inactive. And now after that, what happened? R3 is giving the reply, own reply to the hey, I didn't receive the reply from the neighbor. I will give you the own reply, my reply. And like query, receive a reply from the so after the 180 second, what they are doing actually, they are just going to break the neighbor relationship with the R4. And now whatever the user are sitting behind the R4, they cannot communicate with the R3. Not even R3. They cannot communicate with the R2 and R1. So maybe you have a question, hey Law, what happened? If you're like no link is working fine, now the queue does not have a queue issue, the link get congested. After that, neighborship will be up, right? That's not a big deal. But again, what happened? Can you imagine your neighborship get flapped, right? Your neighborship get reset. And if your neighborship get just reset just because of what? Stuck inactive because of which route? This route. So your neighborship will be reset. In that case, what happened? You will have a some packet. You will have some packet. Now see one thing. Once I lose this information, right? Shut down, lose this information. What happens? Send the query packet. And once I send the query packet, this is what happened. This route 1.0.0 has moved passive to what? Active. FD is unsuccessful. What happened? One reply. I'm waiting for the one reply, right? Remaining reply from the 12 or 2. Remaining reply 12 or 2. What this guy is saying that, hey, my status is what? Our reply status. I'm waiting for the reply for this particular route. And how many second I will move in the active state? So 30 seconds right now. We will go for the 180 second. The next output, if you see, for this route, state is what? So you have a two types of route state. Either it can be a active or either it can be a passive. Passive is what is good. Active is what? I'm actively looking for this particular route. What is FD? Infinite, waiting for the reply. Infinite. And if you see the infinite value as well as see the infinite answer. And after that, if you see reply 1. So now if you should show IP EIGRP, so now if you see I'm deleting this route, right? We see the reply packet from the 2 I'm deleting this information from the routing table as well as and giving acknowledgement. So IP EIGRP, so IP EIGRP topology, I don't have this 100 information because it will only present for the 180 second. If the reply is not coming, if the reply is coming, it will immediately remove that particular route from the topology table. And now the show IP EIGRP topology with what we call over there active, I don't have any information. Previously it was there, but now no. So IP EIGRP topology now, and if you call this guy as what we call pending, can I not pending? This one traffic. So IP EIGRP traffic. Can you see that? Send the 2 reply is coming from the 2 now because now R2 has gave the reply, right? If you see. So after the break the animation, because it has to give the own reply, right? All this thing is happening to avoid all this problem. Can you see that my neighborship got dropped, right? The whatever the user is sitting behind this guy, they cannot communicate with this person. To avoid this problem, we have introduced the concept of EIGRP stuff. And what stuff is going to do? It suppress your query packet. So if I'm not going to send the query packet, will I wait for reply? Question is, answer is no. You're not going to wait for the reply packet. If I'm not going to send the query packet, I'm not going to wait for the reply packet. EIGRP stub, as the name suggests that it is stub, right? It always configure on the stub router. Stub router in the sense of last router. So according to the take example, if you have multiple branch connected over there, so you can configure your EIGRP stub on this router. You can configure the EIGRP stub on this router. You can configure the EIGRP stub on this router, but you are not allowed to configure the EIGRP stub on this router because this is the transit router. Because your packet is moving like this guy, right? Like this, like this. Same thing in this diagram, in this topology, right? You can configure the stub either on this guy or either on this guy, but you're not allowed to configure the EIGRP stub on this guy and not this guy. No, you cannot call the edge router. Edge router is a connectivity with the ISP.
Law, I've got one query here. Like when you say, if like in this topology, you said R4, I mean, the neighborship between R3 and R4 will go down. in case if there is no like reply to the query packet.
Right.
Correct? Is it gonna completely go down, or
Yeah,
like the
it's
neighborship?
completely goes down. It's completely down. It's completely down, man. Completely down. There's no neighborship.
So in that case, for example, if we consider this is just a route from one like from R1, right? It's
Yeah,
just one single route. If
yeah.
just for one that single route, it's going to disconnect the entire neighborship between R3 and R4.
That's what this is the problem. This is the problem is happening. That's why it's a big problem, right?
Hmm.
Stub is on the sea, customer and router. It can be present anywhere, man. Stub router is a what? It should not be a transit. Okay, this is the stub router. This is my company, and in my company, this is the stub router. This should be a stub router. Last order, last one. This should be a transit.
Yeah, customer and router means last router actually.
Yep.
It need not to
The
be the last router. Here I know that 1.1.1.0.0.0 network, I'm learning from somewhere else or from myself. And I'm sure that R4 has no information about it. So that case, I can configure stub right on R4.
Yeah. So, but again, stub is always either you can configure on the router number 1 or router number 4, the last one. But what happened? Okay, this is the recommendation I'm telling you. This is the recommendation that you're going to configure. Okay. But what happened if I'm going to configure the stub on the router number 2? What stub is doing actually? Stop is suppressing your query. Stop sending the query packet. Stop sending query. That's the meaning of
And
EIGRP.
R2 is also not going to send any query packets, right? If R2
R2,
is a stub.
it will affect on the neighbor side.
Okay. So R2 will send query packets if
Yeah.
any
Yes.
network goes down.
Yes. Yes. If see, if I'm going to configure the EIGRP stub on router number 2, what happened? Let me up this guy again. Okay, I'm going to up this guy. And I'm going to remove all the ACL right now. Interface 0/1, no IP, access group, hungry, inbound, and interface 0/1, no IP, hold on time, page no one. Real IP, HRP, universal. All good, so IP, boot HRP for the information. Let's go to R2 and configure R2 as a router HRP 1 PHRP stub.
And this command is going to take effect on all EIGRP interfaces, right?
Yes,
Give this.
yes, yes, yes. Once I put this command out of EIGRP stub, what happened? R2 will exchange the hello packet. And in the hello packet, what happened? They will put the, hey, I'm only going to advertise the connected route and some did not. This is a default behavior. So if you see do show IP protocol, what happened? I have a multiple option. Either I can configure like, I can configure EIGRP stub. By default, if you don't put by default, it will take the connected. Some you have a multiple option. Either you can turn it connected. That's by default. Somebody is by default, right? You have option to use. You can use the redistribute. You can use the receive only. Then you can use the leak map. You have a static only. This receive only is a like what we call those guys. Exception is there, right? You cannot use any other keywords if you're using receive only. It means that I can use all those things. I can use the connected, I can use the summary, I can use the reduced, I can use the leak map, I can use the static as well as, sorry, I can use the static as well at the same time, but you cannot use the receive only. So if I'm going to use the receive only, I cannot use any of the keyword. Connected summary means what? Now R2 will only advertise the connected and summary. So whatever the connected on R2 we have, this information. So R2 will only going to share this information to the R1. So do show IP as a neighbor detail. You can see what happened. I'm suppressing my neighbor is suppressing the query. So my neighbor is telling, hey, I'm going to suppress the query. So don't send me the query packet. See, if I'm going to lose this network, right? I'm not going to send the query packet to this particular neighbor.
So when you configure R2 as a stub, it sends out some message to its neighbors telling it's a stub and you are not supposed to send queries.
Yep.
No, but if I send a query, I should get a reply, right? So that is not blocked anyway.
Yeah,
right?
that's the importance, right? The router should not send the query packet. If I'm not sending the query, I will not get the reply, right? I will not wait for the reply. And what happened? Suppressing the query, my neighbor is suppressing the query, and my neighbor is going to advertise the connected and summary route. So do we have somebody summarizing on R2? No. So do show IP route. How many routes I have?
So if we configure stub, the router will before itself, like the moment we configure the stub, it will update its neighbors that I will be suppressing queries.
Right. He is telling that I'm going to suppress the query, don't send the query back. If I'm going to tell you, hey, don't call me, so you're going to go call me again. No. I'm telling my neighbor, don't call me. So now can I ping the 3 and 4? So that's see the problem what's happening. If I'm going to configure the transit router, I show you the problem. You have to configure the stuff on the R1 and R4. What happened if I'm going to configure the stuff on this guy in the middle of the router? This problem is happening. Now R1 will not get any information from R3, not even that.
R1 is not getting the 34.0 network now.
Yeah, this will not get because R2 will only advertise the connected route. They don't have any summary route, so it only advertise the connected route. If you go back to the R2 and say the EIGRP stuff, you have options, right? If you just put the enter over there, by default it will take the connected and summary. If I'm going to use the receive only, then what happened? I'm only going to receive, nothing advertised. Can I use any other keyword with the receive only? No, I can't use. What I told you, this is the exception. You can't use anything. Go to R1, check that out. Nothing is there.
Lo, can you tell me one scenario where we use receive only? Where is it required? At what point?
Good job. Take example. I'll tell you where should I see. I always telling the person, right? Everything in networking based on the scenario, right? Everything. For example, R2 is receiving a huge amount of route from the R3, like a 5,000 plus route. And I don't want to share any information to the R1. How many prefix list or ACL I have to create? But how many route filtering we have to do over there? Lots of route filtering we have to do
Yes, we have to. Yes.
just for the receive only keyword. to observe it.
I am not going to advertise that whole 5,000
Yes,
routes to my neighboring routers.
exactly right.
Can we place a leak map with receipt, or that's also not possible?
You cannot, even you cannot use the leak map over there. There's no option. And even if I'm going to use the first voltage example, corrected, can I use the receive only? No, not even possible. So receive only is the indivisible. This is how your stuff is going to be marked. Now tell me one thing. Now tell me one thing. On R1, if I'm going to lose the network, which packet I'm going to send?
Update packet.
Perfect answer. I'm going to send the update packet, or in that update packet, I'm going to put the down information. And that update packet contains the infinite map.
Am I going to send a trigger update packet?
Yeah, that's a trigger update packet, right? The any update packet, it's a trigger update packet actually. I can call it the incremental update packet. Some is called incremental update packet. So if I'm going to lose this information, if you capture this link, right? Again, stop capturing, start capturing this guy. Start Wireshark. I'm going to enable the debug right before I'm going to do it. If you go back to the R3 do show IP route, I'm not running 11. Of course, this is the stuff, right? So let's do one thing. Did I shut down this interface? No. Update. I'm sending. Oh, come on. Packet is update, but they contain the infinite matrix. Normally they contain the normal matrix, right? Normally they contain the normal matrix. R2 will process the query packet with the even R2 does not R3 does not have that information. You just process it, right? You give the reply. No, I don't have any information. This is how your EIGRP stuff is going to work.
And
It's
I'm going.
never a recommendation to like. It's again, I cannot say the never recommendation. It's again, it's up to you guys, right? How is your network is, right? Even if your network is like, if your network is something like that, you are going to do the lots of filtering. You do one thing, just enable this stuff. Based on the stuff, I can do the filtering, right? I have all options. Yeah, go on.
Sorry to interrupt you. Can you go back to the scenario? I have a question.
Which option?
I have a question. Can you go back to the diagram?
Which diagram? Or the GNS3?
Yeah, GNS. Okay. Let's say R1 and R4 are configured as stubs. Okay. And there is no stub on R2 and R3.
Okay, stub is configured on this guy. Stub
And
is
R4.
configured. Yeah.
There is no stub on R2 and R3.
Mm-hmm.
Okay. And in this case, the loopback one of R2, that is the two network, it goes down and R3 fails to send a reply.
Yeah, but R2 will not send the query packet to this guy, right? If any if this guy goes down, it will just send the query packet to this guy, right?
No. Loopback will go on R2, not R1.
Okay, you're saying that yeah, stop on this guy and stop on this guy.
And now the loopback of yes.
Now the loopback goes down on this guy. R2 will never send the query packet to any guy.
Okay. Not even to R3.
R3 it will send, right? Because R3 is not neighbor. R3 is not a stub. It will send the R3.
And if R3 fails to send a reply, the neighborship between R2 and R3 can go down.
Yeah, exactly right. You can it will not send the query to this guy again because they separate the query for this guy now.
That I understand. It will not send the query to R1 and R3 will not send the query to R4, but R2 and R3 it's in this.
Yeah.
Okay.
That's why, like, you know, the maximum time what happened, this is the stuff is happening on the DMVPN network, right? Always these guys compare the stuff on this guy, this guy, this guy.
Better, true.
Not on the headquarter branch. This is the EIGRP stuff. Yep. Any questions, anyone? Yeah, all part of this.
So there is no stuck inactive concept in EIGRP stuff, right? It's a solution for stuck.
Yeah, exactly. That see, route has moved in the stuck inactive, and the solution is EIGRP stuff. One minute.
What?
Now.
I mean,
yeah.
yeah.
Yeah, go on.
Without the stub, I mean, without the stub earlier, when there is stuck inactive, you will see the stuck inactive state in router 1, 2, and 3.
Yeah. Yes. So we are removing the stuck inactive now by using the stub routing.
Okay.
Stub routing is a feature primarily designed to improve the network scalability and the stability. Most important line. This stub routing features is most commonly used in the hub and spoke network, hub and spoke in the network synthesis or DMVP network. Like we have a headquarter main branch over there, we have a branch office there, right? This feature is configured only on the spoke router, like should not be a transit. When they configure on the spoke router, the router announces its stub router status using the additional TLB in the EIGRP hello message, right? Because your like you know, I told you that your EIGRP information will send on the EIGRP hello message, right? The stub features. A stub router does not propagate routes learned through the EIGRP to its neighbor with the exception of EIGRP learned routes, right? You can do that leak mapping over there. By default, it will go for the connected and summary. It will enable on every interfaces, right? Where the EIGRP is enabled. And EIGRP stub router features will extend in the hello packets.
One more question.
When
we configure stub router, by default it allows connected and summary.
Right.
It advertise. So connected, it will advertise. Does it also create a summary route on the stub router?
It's up to you, like how you're managing your network. Right? You can create a summary route and you can allow it.
So that means it will install a null route again to create a summary route.
That null zero has a different concept, right? Null zero is like, you know, it's for the loop prevention.
Okay.
Sujit, Chetan, ये देखो. Neighbor of the stub router aware of the stub extender will never send a query packet to the stub router. Neighbor of the stub router. Understand?
Got it. Got it.
This prevents the neighbor from the converging or through the stub router to the remote stub router.
Yeah, got it.
That's it. Any questions, anyone in the EIGRP stub? I'm done for the EIGRP stub. If you have a question, let me know. Otherwise, we'll do the name move.
Now, one request. If you configure stub on R1, can we see the routing table? I just want to see
Of course,
what
right?
it is advertising.
Why not?
Thank you.
So should I remove the EIGRP stub from the router node too, or should I keep it over there?
R2, remove the stub. I just want to see what it advertises. I mean, any router,
Of
it's
course,
fine.
it will only set whether the connected. It will only whether connected or. So now go R2. I don't have any stub configuration on R2, but my neighbor is running with the stub. Which neighbor? 12. So R1 will set the connected information to the R2, R3, and R4. So everyone will receive this information.
Can you go to R1 and show me the routing table?
That's why it's going to be configured. So if you configure on the last stub router, right? So they will not create any issues. All route will be happen. If you configure in the middle, it will create a problem.
Okay, thanks.
So it looks like when you configured it on the end router, you will still see the EIGRP neighbors.
Everything you can see that. Passive interface, what is passive? What sort of passive method?
Will we cover the passive interface concept?
नहीं पता मैं वो मॉर्निंग वाले बैच में कर दूंगा उसमें करूंगा
Okay.
yes what you say cat can you come back again?
So because earlier when you configure it in R2, all the neighbors that you have learned through EIGRP are gone. It's
Yeah, exactly, right. See the problem. Now you understand the problem. Whatever the routes I'm learning from here, I'm not sending to this guy, right? That's the problem is happening in the if you configure the stuff over there. But if you configure the stuff over there on the last route on this guy, there's no issue with the happen. EIGRP. All good? Oh my god, it's blocking masses. L1 goes down, it's in the query packet, but due to the hold on, I'm actually R3 is disconnecting neighbors, R4 to resolve the issues. We can convey the stuff, and then R7 will not receive the query packet because the R5 as the alternate path to release this guy. If R5 has the alternate path, then it will send the positive reply, buddy. Nothing will happen. It will give the positive reply. I think so. You missed the reply packet class then.
This is a condition where we do not have a feasible successor, right?
Yeah, of course.
So there is.
Yesterday we have seen the reply packet concept, right?
Correct.
All cool, guys. So hope I'm clear to everyone the EIGRP stuff, right? Let's do one thing. Let's make our break over the 10 minutes. We'll see in the 3:45 and do the name mode. Okay.
Okay.
Sure. Thank you.
All done.
Ya, Hazan, huh? Yeah, phone so fully mention के issue number time on call की की भाई यार वो विचार रहा हूँ वो तो सो
Now you can deploy, right? You can deploy your EIGRP in the two modes. If I'm going to talk about the deployment of EIGRP, you can deploy your EIGRP in the two modes. One we have a classic and one we have a named. One we have a classic mode and one we have a named. Question is that why we introduce the classic to the name? What's the reason? Do you know when you're putting this command out EIGRP number one, actually you're deploying the classic mode. Actually you're deploying the classic mode. Then what's the reason behind to deploy the name mode? What is the reason behind it? If you have a look, I'll tell you the reason. First of all, this classic mode, you cannot, the name mode you can run in the 15.0 as version and above 15.0 as version, right? Not in the 12. If you just have a look on the R1, if you see whatever the versions we have, it's a 12.4. And if you just configure router EIGRP of the router EIGRP and put the question mark, do we have any option of the named over there? No. So you cannot run the EIGRP in named mode in the 12.0 as version. You have to go for the 15.0 as version. So if you see this is my 15.0 as, and I can run the classic and the named as well as. It's totally up to you. It's up to you which mode you are going to deploy. Okay, but the question is that again, why? What's the reason to behind the name? Why we have introduced the from classic to the name mode? The reasons are very simple. I'll tell you the first reason. The one of the biggest reason of the classic mode to go for the name mode. Now, read this one. With the speed of interface ever increasing, right? If I'm going to talk about the 90s, what happened? It was a very good enough for bandwidth, 100 MPS. It was awesome. And it was super awesome, right? If I'm come to the 2000 and 2002 and then 5 and on 7 and the 28 9, it was good. But nowadays, what happened with the speed of interface even ever increasing, the EIGRP classic metric, it's talking about the classic mode. Classic mode is going to use the classic metric. Classic mode is going to use the classic metric. Name mode is going to use the wide metric, the new version metric. So what is the issue with the classic metric? With the speed of the interface ever increasing, the EIGRP classic metric faced issues with the interface faster than 1 gig. the bandwidth component itself is unable to differentiate between the 10 gig and the faster of the 10 gig. And in addition, the default delay of the component is what? 10 microsecond, that is one on the 1 gig interface. And it cannot be smaller. It cannot be smaller. So the main issue is happening here, right? This is the biggest issue of the classic mode till this point. It means that if you have a link capacity, take example, if you have a R1 over there and this guy R2 and this guy R3 and this guy R4, and if you have a behind the R5 over there, right, and this guy's a 4.4.4.4.4.1 path, and if I'm going to deploy the classic mode over there, take example, nowadays what's the link of this capacity? I can take the 20 gig, I can take the 30 gig, or I can take the 10 gig as well as. What do you think? Which link is better? This link, right? 30 gig. So I need to always forward the traffic through the R3, right? But you know what happened? What this guy line is saying that, hey, this guy is not able to differentiate. Bandwidth component itself is unable to differentiate the bandwidth between the 10 gig and faster interface. So if you're going to send the packet, it will do the load balancing. It will send the packet from this guy, and this guy as well as. हो गया fail. यहाँ पे classic mode. The issue with the classic mode, this guy is not able to differentiate between the 10 gig link and faster the 10 gig link, right? It's not going to do, okay, this is the 20, it's 30 and 10. It's calculating, okay, everything is same. Everything is same.
Because beyond 1 gig, it has the default this thing, right?
What's the delay is happening? One. Minimum
yeah.
this delay is 1.
Yeah.
Can I go minimum delay is 1 over there? Can I go slower than 1? No, we can't go in the classic mode. What is the second issue with the classic mode happening? If you have a look the classic mode, I can go in the router number 1. I put the command router EIGRP 1. Do I have option on IPv6? No. What is the next disadvantage of the classic mode? Go on the interface 0/0. IP authentication. Mode EIGRP number 1. Which mode I have? MD5 is not secure in this year. Even the Cisco recommendation, right? Don't use the MD5. Even Cisco recommendation is don't use MD5. What is the fourth disadvantage of the classic mode? The another disadvantage of the classic mode we have. Okay, if I'm going to do, we have a 2 box in the classic mode, right? In the classic mode, if I'm going to talk about the the scalability purpose, we have a 2 box, config box and interface mode. If you want to do, take example, this guy is over there. If you want to do the router EIGRP configuration, we have to come in the config box. And if I want to do the summarization, I want to go in the interface mode. For example, after some time, I'm planning to do the EIGRP stuff. I have to go in the config mode. And again, I have to do the some hold on time. I'm going to change the hello time and hold on time. I have to go in the interface mode. Again, I have to configure the, the passive interface. I have to go in the config mode. So can you see that we have a two box configuration, right? Scalability is ways. This is not so much scalable. This is the classic mode is not so much scalable. What is the another issue we have? Whatever the new features we have right now in the market, take example, IP, FRR, EIGRP over the top. This features is not going to be supported with the classic mode. So whatever the new features is coming, it only going to deal with the named mode. So to avoid all this problem, this is not a small problem. These are the big problems, right? One of the biggest issue we have a bandwidth issues. To avoid all this problem, what we have introduced the classic mode to the named mode. And nowadays in the market, everyone is recommendation to use the name mode. If you see, very less company right now is using the classic mode. Everyone has changed from the classic to the name mode. And even if your network is like, if your network is configured with classic mode, you can convert your network from classic mode to name mode within a small window. Max to max 1 second. Max to max, just a matter of second. It's just a matter of second. You can convert whole configuration, whole your network, right? Whatever the network you are running, the EIGRP classic mode, 10 router, 20 routers, just put the one command, automatically all the configuration is going to be converted into the name mode. But only the thing is that your router, or you can say that your iOS version, must be supported with the name mode. A node, what I told you is just a matter of second. Of course, the voice traffic is a 150 millisecond. One packet will drop max to max. Again, it's totally depend on the person to person, right? How your network will be. Just a
I'm
matter of
saying that I have converted so many networks. So far, I have not seen any single drop in the conversion. Not even one drop.
Yeah, even so I said it's just a matter of second, right? So this is the reason why we are going to convert the name mode. And guys, name mode is very, very easy to configuration. Instead of putting the EIGRP, I said the router EIGRP, right? What are you putting the command over there? EIGRP number 1. No, I'm not going to put the AS number. I'm going to define the name. Name will be CCI. Or this name is just a logical name. This is just a logical name. And this name is local to the router. So on a router number 1, okay, you can configure, for example, on the router number 1, you can configure the A. On the router number 2, you can configure the B. On the router number 3, you can configure the C. But make sure that they all belong to the same AS number. So name is just a logical name that is just going to tell you, okay, you have moved in the name mode configuration. Now you moved name mode configuration. But make sure that before deploying the name mode configuration, your IOS must be supported with the name mode, right? And after that, what? How many like we have IPs types over there? We have IP. If you want to talk about, we have IPv4 and we have IPv6, right? In IPv4 we have a unicast and we have a multicast. and we have VRF concept as well as, right? We have same thing, unicast, multicast. So which family I'm going to enable? I'm going to say that, hey, I'm going to run with the address family. Which mode I'm going to enable? I'm going to go for the IPv4. By default, it's IPv4, right? Sorry, by not by default IPv4. You have to tell this guy, I need to run the IPv4. And then after that, you need to tell which mode I'm going to enable, unicast or multicast or VRF. By default, it will go for the unicast. If you don't put this keyword unicast, by default, it will take the unicast keyword. This is the optional command. This is the optional command. And after that, you can define the autonomous system number. One. And now I'm going to hit enter. So now after that, you have three modes over there, three boxes. So these are the big box over there. So under this box, big box, what I'm going to do, I'm just going to get the small boxes. Interface mode configuration, topology based configuration, and address family configuration. Interface mode, all the interface related command you can put over there, right? Then you have a topology base, and then you have a address family mode. So does this network engineer go back to the interface mode? I need to put the interface command interface 0/0. I need to go in the interface mode. No, you are present into the name mode configuration. Everything you can do in the single box. You don't need to go beyond the box. You don't need to go beyond the boxes. So if you see over there, what I can do between the R3 and R4, I just put the interface 0/0. This is the IP address will be 12.1/24. This guy will be 12.2/24. And I can configure one loop back or the interface loop back number 1, 4040404, and I can configure R3 as a one loop back interface loop back number 1, 3.3.3.3.3. And I say the router EIGRP, put the question mark, I can define the name, any name CCI, address family, define IPv4 as well as now they can support the IPv6, define which unicast, multicast, VRF. I say the unicast. If you don't keyword, put this keyword, it works. I say that unicast right now, autonomous system or what? Same thing. Which mode I'm? Address family mode. How many things I can do in the address family mode? You can do the use things. All this related command you can do in the address family mode. Do whatever you want to do. Everything, single thing you can do that. I want to advertise my network. I can simply say, hey, I want to enable the routing on the IP network. Which network? This is my interface is 12.1. This is the /24.0. This is the 12.2 now. This is what we have a 3.0.0/8. And this is what we have 4.0.0/8 behind R4. I just said that, hey, network 12.0. And once I put this command, what happened? My interface will be enabled in the EIGRP, so do so IP EIGRP interface. Can you see? And I'm going to send the hello packet. What will be the TTL over there? 15.0 as version. 1. Protocol number 88, Cisco EIGRP. Same version, nothing is different. Even if you open the parameters, even everything is same now. Am I extending the any name over there? No. I'm not extending any name information. Now what happened? If you see, R1 is keeps sending the hello packet to the R2. Sorry, R3 is keeps sending the hello packet to the R4, right? But R4 is not responding because EIGRP is not enabled on this particular interface, right? I have to go on the router number 4. Put the any name up to you guys. Address family, IPv4. Now I'm not going to define the unicast keyword. I just put the AS number 1. And network what? Because your unicast keyword is what? It's optional, right? By default, unicast is working. IP routing command. Remember the first command, IP routing. What is the use of IP routing command? It enables the unicast. And now I do have a neighborship. Is there any differences happening in the neighbor table? Except this part, the name. Everything is same. Now, if you want to advertise the route, for example, hey, I want to advertise this 3.0 route. I have to say that 3.0.0.0 network. That's it. And now R4 will get this information. Do show IP route EIGRP. Any changes are happening over there? I can send my traffic 3.3.3.3.3.3. Nothing changes. If you now apply the authentication, I do have an ability, right? AF interface. I just need to go in the which box now. And now I'm present in the this box right now. Address family mode. I can jump to the this box. See the scalability. I can jump to the this box. I say the AF interface. Which interface we have? 0/0. Do I need to come back into the interface 0/0 mode? No, I just go in the, I'm jumping the boxes by boxes. And now I say the authentication. Do I need to create the keychain over there? No need to create the keychain. Mode, sorry. Yep, mode. Which mode I'm going to use? HMAC SR256, right? Higher than MD5. And I can set the password. 123 CCI. What are these guys giving the message over there? You cannot start your password with the integer number. Always your password should be a character. I say the CCI now 123. Neighborship is break. Which authentication is enabled now? 256 same authentication. I need to put the router number. So sorry, I need to go the AF interface mode 0/0. So your password should be start from the integer, not integer now. Always should be start from the character. All good. What is the next thing now? If you want to do the stub configuration, I can do that. Topology exit, topology base, EIGRP. What the configure? Where is the stub? I think the stub in address family. EIGRP stub. Here's the stub, address family mode. For example, if you want to do the any kind of like the summarizations, not summary, auto summary, you have to go in the topology base. Like see all this configuration, even change the metric, do the like your metric changing offset list, right? Distance, change the AD value of the change. You have to go in the topology. Everything like Previously, what happened? Everything is put in the single boxes, not two boxes, interface mode and the global configuration mode. Now they convert into the single box. Only the thing is changed over there, guys. In the named mode, your bandwidth is called as a throughput, and your delay is called as a latency. These are the terms they have just changed. That's it. The only the term is changed. Throughput means same bandwidth, and latency means same delay. But your delay is now going to calculate into the picosecond, because what is the smallest unit of the delay was happening? One delay, right? Now they convert into the picosecond. It was the 10 second was there. If you're going to convert the one, it will come in the 10 second, right? Now they convert into the picosecond over there. Smallest unit, or very, very smallest unit. And you now the metric calculation is happening. EIGRP was doing the metric calculation, was the 24-bit. EIGRP, if I'm going to talk about the classic mode, is doing the 32-bit. And your what we call the name mode is doing the 64-bit. So if you see your metric now R4, I'll put the command show IP EIGRP topology table, which route? On R4, right? This information 3.0.0. The name, this is my router ID, 404040, the loop back for this particular route. The state is passive is good. What information I have? Can you see the delay is happening in the picosecond? Route is internal because I have advertised by the network statement. But what's the metric calculation is happening? 64-bit. If you look one thing over there, guys, I'll do one thing. Interface 0/0. IP address will be 12.1. Do show IP route EIGRP, do show IP EIGRP topology. Sorry, do show IP route EIGRP, do show IP EIGRP topology. One thing I want to show you. Sorry. See the difference. Your FD value, right? Arvaz, don't write anything. Your FD values. You see that FD is present in your routing table. Why? Your classic mode is doing the 32-bit metric calculation. And this size of this guy is also a 32-bit. The size of this guy, the classic mode is doing the 32-bit metric calculation, and the size of the routing information is RIB. RIB information is also 32-bit. What is the size of RIB right now? 32-bit. What is the matrix calculation during the name mode? 64-bit. The box is 32-bit. How can you store the 64-bit information? Never possible. The size of box is 32-bit. How can you store the 64-bit information? Can you see that the FD is now is the 64-bit matrix calculation, but your what are this different in the name mode? But in the classic mode, same, right? You see that same, everything is same. The thing is that because EIGRP is saying that, hey, I will give you the 64-bit. This guy is saying that, hey, I'm the routing information, my capacity is 32-bit. I can't install. I can't install. So to avoid this problem, what we have introduced? We have introduced the one person, and that person name is RIB, routing information base. And what this person is going to do, whatever the FD value you have, they will divide your FD value with your 128. This is the default RIB for the name mode. And why they are dividing? So that I can put this information in my routing table. So if you divide your this value, right? Calculator. What was this value? 13189.120, right? 13189.12, come on, 120. Same value, right? Divide 128. 128. What I'm getting? 10340, right? See that over there. RIB. Stored in the routing. So why we have introduced the RIB? So that I can put this 64-bit information in my routing information value, because the routing information base size is what? 32-bit. My size is what? 64-bit. It's never possible. I need to divide with the RIB, and RIB to default RIB is what? 128. You can change it from 1 to 255. That's not 0 to 255. It's not a big deal. But again, it's never a recommendation to change the RIB value. Yeah, but it's some ways that you can change the RIB as well, as in the CCL lab questions. This thing is coming, right? But it never recommends to change the RIB, because if you're going to change the RIB, your matrix will be completely changed. Classic mode does not have issues. Issues with the name. So if you see the default RIB is what? Show IP protocol. (128). And what is the matrix version we have? 64-bit. Three minutes active timer, EIGRP stuff. I can change the RIB. If you see, I can say that router EIGRP number one, router EIGRP, this name that we have, address family IPv4 autonomous system on 1, matrix rev skill, right? See, I can change. Okay, so 1 to 255. So change anyway. I said the 200. Now do show IP EIGRP topology table. What happened? You see, RIB has reduced now. Previously, RIB was what? So previously, RIB was 103040 for what? 128. If I'm going to make this guys of 200, then you have a 65945. And if I'm going to decrease it, matrix RIB skill will be 10. What happened? 1318912. So changing the RIB, it will change your matrix value, and that's never recommendation to change it. That's never recommendation to change the RIB value. Never ever. Because it affect your complete routing table information. By default, the metric version is 64. If you see do show IP protocol now, what's the RIB right now? 10 and metric version 64. You can change the metric version. I say the metric version. I think so. Also command. I don't know. So hidden command actually. Now the version has changed. So if I'm going to change the version, what I will do? So I protocol. First of all, see the default version is the default RIB is what 1, and again your metric will be changed. If I'm changing the metric version, if I'm putting the 32 as well as over there, reverse skill is now 1. And if I'm going to remove this guy, it comes in the default behavior 64, right? And now your reverse skill will be 128. So changing the RIB, it's never recommendation. Never recommendation to change the RIB or never recommendation to change the version. One more difference is there from the classic mode to the name mode. In the name mode, that is going to work with the wide metric concept, right? Why I'm calling the wide metric? Because they have a now K6 values. We have a K1, K2, K3, K4, K5, right? We have a K6 as well as. The K6 value is reserved, but if you see, we have the same thing, only the thing is that, what we call over there, your bandwidth is changed with the throughput and your delay is changed with the latency, right? Throughput and latency. Now, the K6 is value, that is this extended metric, K6. That is going to represent the jitter energy and quiescent energy. But this is reserved for the future extension. We are not using it, and that's why always the K6 value will be 0. So if you see somewhere in the protocol as well as, we have a K6 over there, but this K6 will be 0. We are not using this thing right now. Maybe in future they will use it, but right now they are just telling you, okay, we will use this for this percent jitter energy and quiescent energy, but right now they are not using this part. One more thing I want to discuss about the classic, like how to convert. Let's see. Also the conversion, how can you convert your classic mode to the name mode without the taking a long window size? It's just a matter of second. All configuration, if you see right now how the configuration look like, loose run section, EIGRP. I haven't put the unicast keyword. Can you see that it's automatically putting the unicast? I didn't define the unicast over there on R4. I did on R3, but I did not perform the unicast on R4. But it's showing the unicast because this is the default behavior. And see the configuration. Everything you can do that in the name mode. Every single thing, whatever the new things are coming, they are only doing in the name mode configuration. Classic mode nowadays market is not using, right? It's a very it's a huge disadvantage of the classic mode. We have like a first of all, right? If you do the authentication, they just have a MD5, right? enable on enable swipe interface brief. We have a 12.1 configure on this guy. I'm going to configure the EIGRP classic mode right now. Router EIGRP, 12.0, right? And just wait for some time. Do show IP interface brief. We have a 12.2 is there, right? So let's configure router EIGRP number 1 and network 12.0. And what I can do right now, they found the neighborship. Can you see that? I want to convert this guy. I want to convert this guy into the what we call over there classic mode, name mode, right? So this is classic mode configuration. How do I do that? And I'll do one thing, something also. I say that distance. Take example. Distance. I will change the distance. I will say the ED EIGRP number 50 and internal and external for the take example. I set the 70 right now, and EIGRP stuff I'm also doing. So whatever the configuration we see right now, they are configuring the EIGRP classic mode. And have a look. I said okay. EIGRP upgrade CLI. I want to upgrade my CLI. Okay, put the name of that CCI. Just putting I'm just putting the name of the name mode, right? Hit enter. You're saying that hey, do you want to configuration will be converted from the router EIGRP to the router EIGRP CCI? Are you want to proceed this thing? Yes, I want. Same thing you see over there. What happened now? R2 is converted into the classic to the name mode and do show run section. According to the configuration, they will move in the different sections. So you can see topology in the topology base, they move the distance EIGRP, right? EIGRP stuff is configured in the address family mode. And now on a R2 we are running with the named mode. On a R1 we are running with the classic mode. It means that both are backward compatible. I do have a neighborship, right? My neighbor is R1 is running with the classic mode and R2 is running with the name mode. Both are backward compatible. So there is no chance of the packet drop, right? EIGRP upgrade CLI. I can put the different name. Yes. So there is no chance to, there's no chance of the packet drop. So in the CCI lab examinations, right, this thing is coming, right? You have to convert this guy from the classic mode to the new mode. There's a multiples router will be there, right? In the 6-7 router, the complete one side, and they will tell you, hey, you have to configure the name mode. But predefined pre-configuration was like, in the examination, you will get a pre-configuration that is classic mode, but you have to convert it. So what people are doing, they are removing all the command, and again, they are putting all the new commands over there related to name mode. And that, see, they can do that, but again, what happened? They are doing the manual configuration, everything. So sometimes they forget to configure some commands, and that take us some more time, like 20-30 minutes over there. Just put the single command, and based on the single command, you can change, like not change, can convert all the configuration, all the single configuration into the name mode. Every new features, whatever the new features are coming in the market right now, related to the EIGRP, all single new feature that is related to EIGRP is only going to be supported with the named mode. And the benefits, like you can see the benefit, you have authentication HMAX R256. The classic mode does support the MD5 only. Yep, any questions?
If router, I would just like to clarify again, if the router 1 is using classic mode and router 2 is using name mode, they can still form adjacency, no issue.
Yeah, they can still communicate. Forget the agency, they can still communicate. They are backward compatible. They can form the adjacency, neighborship, everything.
Okay.
And
Sir,
use, yeah.
Sir, I'm facing one issue in named mode. Can go back to DNS.
Not here.
Let me see if that's there. Go to R4, show run. Okay, now you have configured the authentication on fast Ethernet 0x0. Okay, now if you do the do show run interface FA 0x0, it will only show you the, yeah, correct. Here also, it only shows the IP address, but not the configuration. That's just the
They will
configuration.
not show you because I'm not doing the under the interface mode, no? That's why.
Yeah. So it's like the configuration got split of the interface into two parts.
Yeah, they are just removing all the. So the troubleshooting wise, it's very easy. You don't need to go in the interface mode and configure mode and check. Just put the single command, and you will have a complete window.
Oh, so it's all in under the address family automatically.
Exactly, automatically everything in the address family.
So one router is configured with classic mode and another router is configured with named mode, right?
Yeah, it works.
Yeah, it works. But what if authentication enabled on R3? So
Then it will not work. It will not work.
okay. So because our classic mode only authenticate MD5, right?
Yep.
Yeah. So in that case, it communication won't be happen.
No, not happen. You have to run with the. This is the one problem. This is the one problem. You can say that if you're considering this is the problem.
Okay, so if you enable authentication, that both the routers should be in the name mode, right?
Yep,
Name mode
yep,
or
yep.
either or classic mode.
Yes.
Yeah, okay,
Either
fine.
if you're going to provide the backward compatibility, then remove the authentication. Either you can put the same authentication, MD5, both the
Yeah,
same.
if you put MD5
Okay,
in classic mode and then another router, if you put the same MD5 in name mode, it will still work, right?
Yeah.
Okay, fine.
Are you gonna receive an error if you do that, if you still convert it? If you
Yeah, of course, you will get the error message. Like conversion. In a conversion, or you're talking of the authentication part?
let's say you did the authentication part, but you forgot it. You still convert it. Are you gonna be aware about that? Is there an error?
Yeah, you will get the syslog message, right? They will for the authentication failure will happen. They will drop the navigation just because of the authentication failure.
Okay.
See this message. This AS number 1 is already associated with the CCI name. If you're trying to convert this, if you're trying to map the another name with the same AS number, it will not work. It will prove the message, hey, AS number 1 is used in the CC. One name, one AS number.
Once we have defined one name for the one AS number, can we edit that name?
Of course, editing the name is not. You have to go and remove the everything in order to CCI completely. There's no editing. I don't think so. There's editing the name is there. Order EIGRP CCI. CCI. Come on. And can change the name. Service family so down. Before no, we have to negate this command. No EIGRP CCI. No, there's no way. Because default is default address only exit service. No, there's no command. There's no way to change.
Yeah, when you give another name, it will start a whole another instance of EIGRP.
Exactly right.
Okay. In that case, while placing the command of EIGRP upgrade CLI, you have to be very careful with the name.
Yeah, of course, that's very important.
Yeah.
So you mean if it is wrong, we have to do it again?
Yeah, you just remove it and do it again. You can remove it and do it again. You can do that. But make sure that whenever you're defining the name should be correct, right? In examination, not in the production. Production will not get any issues, right? They will not detect your mask. Yeah, maybe they will take your job. All good. The name
within one autonomous system, I can have multiple named EIGRP instances.
And Sant जो डालना डाल ले भाई शक्तिमान सुपरमैन वंडर वुमन डाल ले Okay, guys. So here I'm done with the name mode. See you in the next weekend.
Sure, very good session, man. Named mode.
Name mode. It will.